From today onwards, we are starting according to timetable. Physics classes I will teach second intermediate physics. First, I will give thanks to all who are giving this opportunity to take this online class, and particularly Secretary Sir and DS Sir and all the principals and my colleagues. Now, just now I want to take the class, which is about waves. To tell about waves, generally we will hear about a number of waves in daily life, musical instruments, earthquakes, vehicles and machines, and bomb blast. During these times, we can hear number of waves. All these, which I am telling the examples of waves, produces sound. So sound is also wave form. Sound is also wave form. These are all different waves. Let us say, before going to see waves, what is a wave? If you want to say about waves, let us see first definition of wave. While seeing this, okay. I want to give about the definition of wave. A wave is it is represented as a disturbance that moves in a medium or space. Here you have to understand according to definition, a wave represents a disturbance in the particles of the medium or space. Both these two we have taken, medium or space. First, let us see what is this medium and what is the disturbance. Whenever a medium is considered, medium is of three types: solids, liquids, and gases, and also plasma state medium is also there. We are not considering that. Only medium, generally waves can produce through medium means that is a solid, liquid, gas. Generally we will take. What is the importance of this is, this consists of particles. Particles disturbed by receiving energy. Disturbance means how it is possible? Due to receiving energy, disturbance occurred. Whenever we are taken a solid one and you beat with another solid one, then what happens? These two solids, while beating another one, a sound is produced. Sound waves are produced. So when the sound wave is produced, the particles of the medium are disturbed. Okay, while these are disturbing due to this energy, while you are beating means you are giving energy to the particles. Therefore, the receiving the energy, the particles starts to vibrate. Here you should remember, particles does not move from one place to other place. The wave means here transmission of this energy from where the disturbance is started. This disturbance is given to the next particle. So the energy is transmitted. Disturbance means energy. Energy is transmitted to next particle, and the next particle taken this energy and given to another particle. Like this continuously, this energy is given to particles. Like this, energy transmission takes place. This is wave formation. The waves can travel like this. The sound waves travel in air. Generally, speech is also the production of waves. Speech means production of waves. And hearing, what is hearing? Amounts to their detection of this energy of speech. Speech is detected by hearing. So now this energy, that is which we are talking about, wave energy, is transmitted to one point to another point through particles. But here we have to remember, the particles does not move. It means the medium do not travel from one point to another point, but the particles vibrate from its mean position. Particle starts to vibrate from its mean position. So like this, vibrating the particles, sound energy is transmitted. Sound is, all sounds are waves. You should remember, but not all waves are sound. All sounds are waves, but not all waves are sounds. Why? Because in general, while these, according to these waves and propagation of wave, production of wave, study of these waves, all these are taken, different scientists studied about the formation and propagation of these waves. Those scientists' names we can see: Newton, Sir Isaac Newton, and de Broglie, and Christian Huygens, Robert Hooke. These are the scientists who studied about the propagation and formation and nature of the waves, how they travel in the medium. Let us see, based on their classification, how the waves are transmitted, what the classification of these waves. Generally, whenever you are talking about waves, in this example, I am talking about sound waves and also light waves. Example of waves, we can take sound waves. We have already discussed about sound waves, and light waves are also different from these waves. And finally, all these waves are classified according to this one. This is, we can see, classification of waves: mechanical waves, electromagnetic waves, matter waves, and gravitational waves. There are 4 types of waves we can see. Let us see first what is mechanical wave. Mechanical wave means due to mechanical force, these waves are produced. That's why this is called mechanical wave. So how the mechanical force is transmitted in the particles of the medium? This is due to the elasticity of the medium. When the energy is taken by the particle, immediately the particle will move in one direction. So they will give this energy to next particle, as we have discussed earlier. So like this, these mechanical waves again further classified as transverse and longitudinal waves. We will discuss after discussion of these mechanical waves. Some more examples you can take: the waves produced in the strings. All musical instruments can produce these mechanical waves. Why? The strings will vibrate horizontally and sometimes vertically. In solids and liquids, these particles vibrate and give different types of mechanical waves. All the sound waves, you can consider these mechanical waves. Now, coming to the next, electromagnetic waves is different from these mechanical waves. Why? Because mechanical waves requires a medium. If there is no medium, no particle is there. Particle medium is present, then only mechanical waves are formed. But in case of electromagnetic waves, there is no medium. How these waves are produced? Let us see. Electromagnetic waves are produced due to the changes in electric and magnetic fields Due to the change in these electric and magnetic fields, some waves are produced. Those are electromagnetic waves. So the electromagnetic waves are again further classified in different types of waves: microwaves, X-rays, all these X-rays and visible, invisible rays, all light waves. All light waves are electromagnetic waves. Every light wave is a electromagnetic wave. In the light wave, there is perpendicular components of electric field and magnetic field. Due to electric and magnetic fields, the electromagnetic waves are produced. So the electromagnetic waves are further divided in 7 parts. You know, in your SSC, you have studied about these electromagnetic waves and what are the ranges of these wavelengths, all these. So all these waves will travel. The important thing is all the velocity of these electromagnetic waves is equal to the velocity of light in vacuum. That is, what is velocity of light? 3 into 10 power 8 meter per second, 3 lakhs kilometer per second. That is the speed of the electromagnetic waves. This is electromagnetic waves. Now coming to the matter waves. Matter waves are different from these electromagnetic waves. Matter consists of a substance. Substance, again further, while studying deeply, these are consists of smaller particles, which we call it as atoms and molecules. And further, the atoms consists of 3 types of important particles, which we call as electrons, protons, and neutrons. While studying about all these electrons, protons, and neutrons, these are related to nucleons. In the nucleus, there are proton and neutron. Around that, according to atomic physics, we know that electrons revolving around the nucleus in the circular orbits. According to Bohr's theory, these rotating electrons produces some energy. How the electrons produce energy? Electrons revolving in fixed energy levels. When energy is received by the electron, it will jump from one orbit to another orbit. While they are jumping from one orbit to another orbit, they releases the energy. Vice versa, sometimes when the electron jumps from higher energy to lower energy, it receives the energy. So like this, while transmission of electron from one orbit to another orbit also produces energy. That energy is also waves form, that are photon waves. Those are called photon waves. The energy is called photon. According to quantum physics, it has to h nu. The energy of h is Planck's constant and nu is its frequency. In a special chapter, we will discuss about these matter waves. Here we are going to see this is when electrons are transmission, excited electrons gives matter waves. This is one example. And another one, radiation, when nuclear bomb explosion takes place. In these 2 cases, radiation means radioactivity, uranium, thorium, like this radioactive elements continuously produces alpha, beta, gamma rays. These rays also in the form of matter waves. These are very dangerous. Matter waves are very dangerous among all these classifications. Radiation, whenever there is a radiation and explosion takes place, nuclear fusion and nuclear fission, these 2 also produces bombs, hydrogen bomb and atom bomb. How the atom bomb is produced? An atom of uranium or uranium is taken. In that nuclei, we have to introduce a nuclear neutron. In the nucleus, when the neutron is entered, it is divided into thorium and krypton, and while they are dividing, they also releases energy and radiation energy. How much? Very enormous energy releases. So bomb explosions also gives some waves, that is matter waves. So mechanical waves, electromagnetic waves, and matter waves, these are all different types of waves produced. And next, coming to last one, that is gravitational wave. Gravitational wave, what does it mean? All this solar system is bounded by gravitational force. Every celestial body we call planets and stars. All these are called celestial bodies. All these celestial bodies are bounded by a force, which we call it as gravitational force. So earthquakes, when earthquake takes place due to some changes inside the interior of the earth crust, earthquakes and volcanic eruptions also produces waves. These are called gravitational waves. Earthquakes and volcanic eruptions, and also meteors and comets, falling meteors and these comets falling on the planets we can see in the night times. These are also produces light waves, and these are due to gravitational waves. So like this, general classification of waves are 4 types: mechanical waves, electromagnetic waves, matter waves, and gravitational waves. Actually, each wave has been studied in a special chapter, but this lesson, first chapter in intermediate waves chapter, deals only mechanical waves. First, mechanical waves, how these are produced, mechanical waves in strings and pipes, and velocity of sound. These 3 topics we have to cover in this mechanical waves. Now, let us see, mechanical waves are 2 types. First one is transverse wave. What is transverse wave? Mechanical wave we have already discussed about the just definition. Due to the vibration of the particles of the medium, mechanical waves, due to mechanical energy, these waves are produced. Vibration of the particle gives mechanical waves. Means based on the vibration, these are further divided into 2 types: transverse and longitudinal. Let us see now what is transverse wave. As per the definition, when the particle vibrates perpendicular to the propagation of wave direction, then we call it as transverse wave. Let us see the definition. Wave in which the particles of the medium vibrate in perpendicular to the direction of wave propagation. Understand? Wave particles vibrate. We should remember this word, vibrate, not move. Wave particles of medium moves in perpendicular, we should not write. Only vibrate. Vibrate means move from up and down in perpendicular direction of wave propagation, means from the mean position they will travel up and down perpendicular to this one. When these are traveling, you can see this type of waves, transverse waves in stretched string. Stretched string, what we have already discussed. Musical instruments, generally musical instrument consists of a string instruments or a membrane, tabla, like that. We can see a membrane. While you are beating, the membrane vibrates. While this vibration of the membrane, what happens? It will also produces a sound. While these are vibrating, so while this particle vibrates first, object vibrates once, the vibration of the object given to the particles. So the particles vibrate perpendicular to the direction of wave. This is stretched strings, not only waves on a stretched springs also. We have taken 1 or 2 springs are taken, and stretched springs, and also some other instruments. All these in vehicles, machines can produce these. And now coming to this transverse wave diagram. What is transverse wave? You can see diagrammatically in this figure a blue line and a straight line, which is called a mean position of these particles. Straight line is mean without any energy. This is the condition. Now blue line indicate vibration of the particle takes place perpendicular to this black line. This is mean position. Perpendicular to the mean position, the particle is vibrating, then you can get this type of wave. When you take a thread, one side you have to fix it or move up and down on another side. You can see in the thread, you can see this type of transverse wave. So in this transverse wave, when the particle vibrates in maximum in the positive direction upwards, that is called a crest. Maximum amplitude is taken, that is crest. At the same time, when the particle vibrates direction, negative direction minimum, in the opposite direction, that is called trough. So whenever a transverse wave is formed, crests and troughs simultaneously, crest trough like this alternatively forms. This is formation of transverse wave. Then what is the amplitude? You have to know these definitions. Some amplitude is maximum positive displacement. Don't think amplitude is also negative side also you can see, but it is not called amplitude. That is only displacement. Displacement may be positive or negative, but amplitude is always you have to consider positive direction, positive displacement. Maximum positive displacement of the particle is called amplitude. So you can see amplitude here. And similarly, when there is a wave, we have to consider wavelength. What is wavelength? Wavelength, according to its definition, the distance between two particles of same phase. Here phase means direction and position. Direction and also position. These two combining, a scientific term we have to use phase. Where the two particles of same phase means both positions of the particles or both the direction of the particles should be same. Where you can see this type of particles, number of particles you can see during this transverse wave, but in general, easily to understand, we can take two consecutive crests. You observe two crests as shown in this figure. Two consecutive crests are considered. The distance between two consecutive crests is also a wavelength. Why we have considered these two as wavelength? First crest and second crest, immediate second crest, both particles have ready to fall down, is it not? So both the direction is same. Both the particles direction is same, and at the same time, the height of the particle while you are considering the mean position. Mean position means the black line. Initially, what is the line we have drawn before drawing this diagram? That we have to tell as mean position. From this mean position, the particle position, both these two crests same. Height is same. So the position and direction consecutive crests is same. Therefore, this distance, the horizontal distance, we call it as wavelength. Similarly, if you are considering a trough, while you are considering a trough points, here the particle is both sides, consecutive trough you have to consider. Again, in these troughs, the particle is ready to move up. The direction is upward direction, both consecutive troughs. So both the direction is same. And what about position? Position is also same. In negative direction, negative displacement positions of the particles. Where is the minimum displacement? That is at the point of trough. So these two troughs, the points, both these two are in negative direction. Therefore, you can see it is wavelength. So, and also you have to show direction of travel of the wave. In the transverse wave, in this diagram, you can see clearly. So, during transverse wave, first what you have to tell, what is transverse wave? Waves produced due to